Hi, Science 20s. It's Mr. Riley here again. One more video this week. I'm going to teach you how to use a new formula that we haven't seen before. So we've been talking about uniform motion versus non-uniform motion. Uniform motion is when we're going to have something moving at a constant speed. It's not speeding up. It's not slowing down. Non-uniform motion is when we're going to have an object that's going to be speeding up or it's going to be speeding down. Or speeding down, slowing down. Now, for uniform motion, we have a formula that looks like this, right? Velocity equals distance or displacement over time. We can manipulate that to find our displacement. Let's put an arrow over there so it's right. And we can also manipulate this formula to find time. If we want to find time, it's going to be displacement over velocity. So that's all for uniform motion. I cannot use this formula for an object that is speeding up or slowing down, accelerating or decelerating. So I had to use something a little bit different. So this is page 23 in your notes. If we're looking at this, we're talking about the context of where we might use this in the real world, and talking about where people designing roads have to use these types of formulas to figure out how far or how long like an exit lane or an on-ramp onto a freeway has to be in order for vehicles to speed up or slow down in the distance or the time that they need to. So we would use something like this formula. So this formula looks really similar to this formula. But the difference is we've replaced the V with this whole thing. And so what this is I'm going to actually take my initial velocity, so my VI, I'm going to add it to my final velocity. I'm going to divide that value by 2. So whenever I'm doing that, I'm taking two values, adding them up, and then I'm dividing by 2. What I'm really finding here with this is my average velocity of my moving object. And so I'm going to take the average velocity, multiply that by time, and I'm going to get my displacement that way. So let's look at an example of this. So here's example number 1. So how many meters long must a merge lane be on the White Mud Freeway to allow vehicles to safely accelerate from 60 kilometers per hour to 100 kilometers per hour in 10 seconds? So I know I have my V initial, I have my V final, and then I also have my delta T. Okay, so I actually have, everything I need to solve this problem, but I do have one step that I need to take. If I'm looking for, if I'm using seconds over here, I have to be using meters per second here. So anytime you're dealing with non-uniform motion, you guys, I want you to make sure that your velocity is meters per second and your time is seconds. And so we have to change these. So if we think back, I have 60 kilometers per hour. If we think back to how we did this conversion, we take 60 kilometers per hour. I want meters. It's 1,000 meters for every 1 kilometer. Kilometers will cancel. And then I want seconds on the bottom. So my hours are going to cancel here. If I put my 1 hour, and this is in my data booklet, 3,600 seconds. So remember, we did learn a little bit of a shortcut to this, where multiplying by 1,000 and then dividing by 3,600 is the same thing as dividing by 3.6. So let's just get that value here. So we're going to take 60 times 1,000 divided by 3,600. 60 times 1,000. I could put brackets around here just to be safe. I'm just going to press my equals here. So I get 60,000. I'm going to divide that by 3,600. And I'm going to get 16.67. So I don't want to round this value too much because I only want to round at the very end. So if possible, you can use that value in your calculator. But this is going to be meters per second. And then let's do the shortcut way for the V final. So if I'm starting with 100 kilometers per hour, I can just divide that by 3.6, and it's the same thing. So I'm going to take 100 divide by 3.6, and I'm going to get 27 point, let's say 78. So 27.78 meters per second, and then my time is 10 seconds. Okay, so if I look back to my formula, my displacement is equal to my VI plus my VF divided by 2. That's going to give me my average velocity, and then I'm just going to multiply that by my time. So if I plug in my values, I'm going to have 16.67 meters per second plus 27.78 meters per second. Divide that by 2, and then I'm going to multiply that by my time, which was 10 seconds. So I'm going to put all that into my calculator. So let's do this here. So I'm going to put a couple brackets. Okay, so 16.67 plus 27.78. I'm going to close that bracket, and then I'm going to divide that by 2, and then I have another bracket. So I just did this whole part of the equation right here. And then what I have left to do is I have to multiply that by 10. And I'm going to get this answer right here, 222.25. So 222.25. And my units here are actually going to be meters. This seconds right here will cancel out with these seconds right here. So I'm going to have my answer is going to be meters. And then I have to worry about my sig digs as well. So I actually only want, I'm looking at my question, I only want 2 sig digs. So I need to put this in scientific notation. So I'm going to take my first 2 sig digs. So I'm going to end up with those, with a 2 and a 2. And I'm going to move this decimal 2 places to the left. So I'm going to get 2.2 times 10. And since I moved it to the left, and this is a big number, okay, greater than 1, it's going to be a positive exponent. 2.2 times 10 to the 2 meters. Okay, so that's how long that my, was it an on-ramp, merge lane, has to be. Okay, so I hope that helps. I want you guys to do the practice, and